electric current, electrons as charge carriers. We know that matter is made up of atoms. An atom has a nucleus at its center. Inside the nucleus, there are protons having positive charge and neutrons with no charge. The negatively charged electrons revolve around the nucleus. In metals, atoms are closely packed. These atoms have some loosely bound electrons. These electrons act as charge carriers and are called free electrons. The motion of free electrons gives rise to electric current. Thus, electric current can be defined as the flow of electrons in a conductor through a particular cross-sectional area in unit time. Current flow in a wire. Random and drift speed of electrons and the electric current. At room temperature, the free electrons in the metal wire move randomly in all the directions when no electric source like a dry cell or a battery is connected to the wire. When a source of electricity like a cell or a battery is connected between the ends of the metal wire, an electric force acts on the free electrons present in the wire, making them to move towards positive terminal of the cell or the battery. The electrons gain velocity in the direction of the electric force. This velocity gets superimposed on the random velocity of the electrons. As a result, the electrons in the conductor move with a certain average drift speed towards the positive terminal of the cell or the battery. This flow of electrons constitutes the electric current in the wire. Now, let us consider the flow of charge carriers through a metallic conductor of a given cross-section. Let Q be the net charge flowing through the cross-section of the conductor in time t. Then the current I flowing through the cross-section is given by I is equal to Q divided by T. Hence, current through a conductor is the flow of charge carried per unit time across the cross-section of the conductor. Do you know in which unit do we measure the magnitude of electric current? We measure the magnitude of electric current across a conductor in Ampere. One Ampere. The SI unit of charge is Coulomb and is denoted by C. Time is measured in seconds. In SI unit, current is expressed in ampere in the honor of scientist Andre Ampere and is denoted by symbol A. If charge is 1 coulomb and time is 1 second, then 1 ampere is equal to 1 coulomb divided by 1 second. Now let us define 1 ampere current. If 1 coulomb of charge is passing through any cross-section of a conductor in 1 second, then the amount of current flowing through it is called as 1 ampere. Small currents are expressed in terms of milliampere, MA, or microampere, μA. 1 milliampere is equal to 10 to the power minus 3 ampere. 1 microampere is equal to 10 to the power minus 6 ampere. Let us learn about the contributions of Andre Ampere, after whom the unit of current is named. Andre Ampere. Andre Ampere was a French mathematician and scientist who carried out important experiments on electric currents. He established a relation between electricity and magnetism. The SI unit of measurement of electric current, the ampere, is named after him. Let us solve some numerical problems based on the topics we have studied. Numerical problems. Problem 1. A current is of 0.2 ampere is flowing through a bulb for 5 minutes. Find the charge that is flowing through the circuit. Solution. Let us first write given quantities. Current I is equal to 0.2 ampere. Time T is equal to 5 minutes, which is equal to 5 into 60 seconds, which is equal to 300 seconds. We have to find total charge Q flowing through the circuit. It is given by Q is equal to I into T. Substituting given values of current I and time T, we get Q is equal to 0.2 multiplied by 300. Therefore, Q is equal to 60 coulomb. Hence, the charge flowing through the circuit is 60 coulomb. Let us do one more numerical problem. Problem 2. A charge of 420 coulombs is flowing through a circuit for 10 minutes. Find the current in the circuit. Solution. Let us write the given data. Charge Q is equal to 420 coulombs. Time T is equal to 10 minutes, which is equal to 10 multiplied by 60 seconds, which is equal to 600 seconds. Let us find the current I flowing through the circuit. It is given by I is equal to Q upon T. Therefore, I is equal to 420 divided by 600, which is equal to 0.7 ampere. Therefore, the current in the circuit is 0.7 ampere. Now, let us do an activity to understand that a closed path is needed for the electric current to flow through a conductor. Activity. When you entered your school for the first time, you might have wondered how to locate your classroom, laboratory, library, and the office. Let us sketch a diagram indicating the path one should take while going to the office, from the classroom and back to the classroom. Assume that you are standing outside your classroom with your back to the entrance. First, walk 10 meters to your left, then turn right and walk 15 meters straight. You have reached your science laboratory. Continue walking for 10 meters more and turn right and walk 20 meters. You are in front of your school library. Now take a right turn and walk 20 meters. You reach to the school office. Walk 5 meters straight before you take a right turn to reach back to your classroom. Thus, we have sketched a map to show the path to be covered. You followed a closed path and returned back to the point from where you started. Electric current needs a closed path to flow through the circuit. In an electric current, electrons from the negative terminal of the cell travel along a closed path and reach the positive terminal of the cell. Electrical circuits are represented by circuit diagrams, which are closed paths through which electric current flows from one point to the other. Let us understand how we can sketch a circuit diagram using symbols for various components.